almost.
Just keep on your next. Okay.
Right, okay. Check if it's... Alright, hi everyone. So, good evening. And advance happy Christmas for wearing our jumpers.
High quality show.
Yes.
Okay,
can everyone hear us? Can you let us know? Yeah. Hopefully everyone can hear us. Are you hearing us in the broadcast? Hold on. We're just checking. Make sure that everyone's actually hearing us.
Yeah,
okay.
Cool.
Okay, perfect. Right. So yes, I'm Jen Ashby. I'm one of the organizers for Svelte London.
Hi, I'm Scott. So I'm also one of the organisers as well. And we've got a couple of people to come and talk to us about what we're talking about. Routify. So we've got a pre-recorded talk. We're going to play right now, and then Q&A afterwards. So.
But before that, Willow, if you want to join us and say a few words. And Pete, you want to just come up and join us? So we've got Penguin, you know him as Penguin on Discord, and Willow is Ghost on Discord. So we're just calling them to say a few words. Whatever you want to say.
There we go.
Yeah, I think that's all you want to say. We're happy with that. So I think what we're going to do, folks, is we're going to just get on with the first talk, and that's going to be reached about around 5, and that's going to be followed by a live talk by Scott, and then 2 more talks. So on with the show, I guess. Okay, Scott will actually do this because it's his lockup.
Right, let's just. How do I stream out? This one? And then I guess I've got to do.
Sorry about that. We're just going to sort that out.
So we're now ready to run our SvelteKit code CSS class.
So we need to add it to the stream.
What I need to do actually is share the audio as well.
Oh yes.
Share system audio.
Yep.
And then entire screen. Get that? And then you can switch over to here. Play this one.
Hi, Svelters.
Oh yes. Okay. Perfect. Okay.
My name is Jakob, and I'm here to give you a peek at our upcoming Routify tree. It's still work in progress, so the final product may diverge a little from what you see here. So to get started, the first thing we need to do is create a new app. There are a few different ways to do this, but here we'll just use the CLI. Once we've created a new project, we're going to open it in VS Code. Before we can run our app, we need to install our dependencies. We're also going to add a plugin called Index by Name. This plugin lets us arrange our files by a number which we assign them, but more about this later. So we're now ready to run our app. To avoid getting caught up in CSS classes and styling, we're going to add Pico CSS, which handles all that for us. Next, we're going to create a few pages. We want these pages to be ordered correctly, as they will be the basis for our generated navigation later on. The plugin you saw earlier will internally strip the number from each file or folder and assign the number to a meta property called order. In Routify, meta is a collection of data assigned to each individual route node. To verify that our folders are working, we're going to create an index file and visit it on /1. A module file is the same as a layout file. Often when helping users build modules, such as admin, account, or products, the most effective advice has been to think of layouts as modules. These modules handle everything within their scope, such as guards, shared data, and layouts. A module can of course still contain a layout, but the name should help suggest that there is no type coupling between the two. Before we continue on, we're just going to copy-paste a few utilities to handle GitHub data. You can freeze the video or visit the repo for this project to see what the file contains. Next, we have build-time metadata. In Routify 3, it's now possible to generate metadata at build time. This is done by creating a meta.js file next to the component file. Here we're going to pull data from API and store it locally. Our fetch repos function is a small AXIS call to GitHub, and below we have a function that converts Markdown to HTML. Lastly, we have a function that converts relative image URLs to absolute URLs.
If one of us tries to pause it, I'll just pause it and then go back here. How do you take out the camera? Hang on, it's this one,
To consume our build-time metadata, we're going to import the meta helper. The meta helper is a pseudo store, so we need to prefix it with a $sign. The URL helper converts file paths to browser addresses. For dynamic pages like the project page we're about to create, we can provide slugs and query options in the second parameter. As you may have noticed, we're creating our project index in the module instead of in a dedicated index file. We're doing this because we want the project page to be a pop-up that overlays the project index. Before we create our project page, we're just going to create a slot to render the page in. For our project page, we're going to need a few helpers. The node helper gives us access to the parent module, which then gives us access to our stored meta. To find the correct repo, we're going to find the repo that has the same name as our project. The project name we can find in our params helper. To make sure our project displays as a pop-up, we're going to copy a small bit of CSS. We're also going to create a link to the parent page, which we disguise as a close button for a better pop-up feel. Now, a common concern with pulling API data is costs and limits. In our case, GitHub has a rate limit of 60 requests per hour. To get around this, we're going to persist our data by calling fetch repos from our persist helper. What it does is store the return value as JSON on disk. On subsequent calls, it will return the stored data instead of making new calls. Since we don't care about stale data in development, we're going to tell persist to update only on production builds. We can see our stored data in the persistent folder. Depending on use case, it may make sense to commit this folder to GitHub. Another concern for our build-time data is size. On a large-scale project, it would make sense to split the data into smaller chunks. We can do this by using the split helper. Here we're going to split the readmes into separate modules. Since we're using native server-side rendering for this example, we need to handle our dynamic imports in a module script. We do this by moving our logic into the module. Since we can't import component-specific helpers outside of components, we're going to get the current node and parameters from the callback instead. Lastly, we're going to return our result readme to the component. Since our readme was converted to a dynamic import, we have to call it to resolve it. We can then access the readme through our component context, but we could also have used a helper. If we then go to our Networks tab, we can now see that each readme is imported on request. The last vital part of our small app is navigation. We're going to create a navigation file and generate our links based on the children of the module that imports it. To see if a given link is active, we're going to use the isActive helper. We then need to create a module where we can import our page and navigation. After that, we have working auto-generated navigation with active route highlighting. The last main feature in this video is multi-routers. While Routify can have multiple routers share the same address bar simultaneously simply by creating a new router component, we're going to have only the active router use the address bar in this example. This gives us a cleaner URL while providing us with the benefits of multiple routers. To accomplish this, we're going to use inline nav instead of our usual router component. Inline nav returns the children of the current node as well as the index of the active child route. Since inline nav is going to show all routers on the same page, we're going to organize them horizontally. We are then going to use the index to position the canvas at the correct page. As you may have noticed, clicking the project's link brings you back to the project's index. For certain use cases, this would not be desired, and we would instead want to persist the router state. We can solve this by passing the nested pages to our navigation component. We then add a custom function that returns the active route of each router. You will now see that our navigation links to each router's active page rather than its route. The last thing we want to add to our app is a small progress bar that shows on page change. For this, we're going to import pending route, which is a store that contains the loading route. If there's no route, the store is empty. Here we reset the progress to 0 whenever there's a new pending route. We're also going to hide the progress bar whenever there's no pending route. After that, we just need to import our loader in our main module. And of course, since we don't have any slow endpoints, we're just going to simulate one. So there you have it, a peek preview of some of Routify's new features. At this point, I imagine some of you are thinking, does this work with server-side rendering? What did it have to do with Kit? And I didn't get half of that. So it turns out that covering some of the new features of Routify was far more time-consuming than predicted, even if we only covered the tip of the iceberg. Routify follows a Lego approach where everything is composable and replaceable. We aim to ship with healthy defaults, but under the hood, you can extend almost any part to make it your own. So to circle back to Kit, you can right now put your Routify project inside of Kit by creating a catch-all route and redirecting it to Routify. We can do this at different endpoints for a multi-router solution, or we can do it at the root index, like we're doing here. As you can see, we're preloading a route in Kit's load function. This ensures that our route is fully loaded for server-side rendering. In the near future, it may be possible to use Routify in Kit without having to use catch-all endpoints. This is something we're looking into with Ben. As for server-side rendering, Routify 3 supports both native SSR and third-party solutions like Spazzer. If we disable JavaScript, you'll see what that looks like. So to wrap this up, thanks for watching and thanks to everyone supporting the Svelte community, and a big congratulations to Rich on his new job with Vercel. We'll be showcasing new features on Discord and Twitter, and we hope to see you there.
All right, so thank you, Jacob. Great talk. Looks like it's me now.
Yeah.
Do apologise for the difficulties we're having. We're having a bit of some issues with getting set up. So we'll just move on to my talk, and hopefully it's okay for everyone. And yeah, we'll see how it goes. So, just going to share my screen. Get my entire screen. And entire screen. Okay. I'm hoping everyone can hear me. Huh? So, maybe I've got a shout. I don't know. Camera's still on there. Do you want to leave the camera on there? Okay. Alright?
Yes.
Everyone can hear okay? Okay, cool. So, still getting the content out. So, my name's Scott. I'm a developer advocate at Graph CMS. I've been helping out with this meetup, the last one and this one. I'm also helping out with the Svelte Society projects, Brittany and SvelteKit. And got a couple of workshops we're building with SvelteKit and Routify. Most recent one was GraphQL Galaxy, Jamstack Conf in October, and done Jamstack Explorer's mission as well. So if you're interested in going through some of that material, you can check that out. And also a countdown, which is very important. Well, I've got the pictures to show. So let's move on to the next slide. So as with any sort of talk like this, I'm going to put out the past to justify the present and where we're sort of going next. So in the past, if you want to have a website with content on it, you do something like an FTP client, like FileZilla. That's what I was familiar with. And you just go drag and drop the file onto your server somewhere and just hope that everything went okay. That's still some people's reality. Some people still do that. But let's not dwell on it too much. But the reason for that was you always need to get a developer involved if you want to change some content on your site. So this is how the CMS was born. And so it just allows you to get your changes to the site in a managed way. So let's take a look at the visual CMS. So website based, wasn't really many mobile phones back in the day. Very heavily theme based. I always remember trying to dig to like a specific thing on a WordPress site. There's all sorts of types. There are server rendered, tightly coupled, so front end and back end are sort of together. You pay for everything, so if you wanted to have a site on the internet, you had to go buy a server, put everything on that. That wasn't cheap. And it was often slow, so this was the round trip from the browser to the database to go collect that view and bring it back to the browser and often slow things out. So that's where we are with that. So let's take a look. Some people might recognise these. These still take up a good 30% of the internet. Well, I know at least WordPress does. And this is a lot of people's current reality anyway. It's still wonderful. But I'm going to talk about where I am, where a lot of people are with this sort of thing. So, in the present, JavaScript developers, there's a lot of terminology and buzzwords and hype. I'm not here to talk about Web 3. Tangent. So, I want to talk about service. Everyone get what service is? Yeah? So, serverless. You don't make calls to a specific service. Make calls to an API. API abstracts away the server. Guaranteeing uptime, reliability, scalability, all that jazz. So, serverless. Headless. You don't make calls to a specific service. Make a call to an API. API abstracts away the server. Guaranteeing uptime, reliability, scalability, and all that jazz. So, are they the same thing? Right? Anyway, so let's look at where we are now. This is the headless world we're in. So, this is how we sort of get omni-channel content distributed to our mobile apps, our websites, our in-store screen displays, fridges, stuff like that. So the Headless CMS, where it stands in our sort of arena is front-end agnostic. Which means your developers are really concerned about the framework. You know, they can look at the target, they can make it for anything they want. They're mostly quite a lot of the solutions out there at the moment. Decoupled, hence the term headless. There's a lot of developer flexibility that comes with a Headless CMS. And you get great continuous integration, continuous deployment with GitHub pipelines, great services like Routify really sort of help out with that paradigm. So, future, GraphQL. So, I don't want to make it sound like a sort of Phoenix-like sort of thing, but GraphQL, I would say it's where it's at. I'm not going to get on the flat train with that sort of thing. I do use it a lot. So, GraphQL, simple to understand, get what you ask for when query and stuff, and you can use it on the client and server side. So, let's take a quick look at a GraphQL query. So, this could be our products model, let's say. And we can go off and get the name and description of that product, rich text. But from third-party API, we can also grab whether it's in stock or not. So what we do with GraphCMS is content federation, which is just a fancy way of saying we're unifying API endpoints for our users. So it's good. I like GraphQL for that, and that's a really good feature we've got in GraphCMS. So, what I'm really here to talk about is Svelte, and more importantly, we talk SvelteKit. So, everyone knows how to get started with Svelte, I hope. Just waiting for SvelteKit to get to V1. Then we're going to go to Svelte next, it's going to fall away, and then Svelte is going to be our one-stop shop for any project we want to make. Okay, so let's talk about SvelteKit for a minute. Oh, next stand next to it.
Where is the chair?
I want to keep walking. Anyway, well, let's talk about. I could possibly bring on next bit. SvelteKit GraphQL. So, there's some good client-side tools we can use. There's Houdini and Urkel. So I'm just going to go through using a couple of these. So first up, I'm going to talk about Urkel. Urkel is universal React query library, but it does have Svelte bindings, and it's a very nice tool using the client. So if you want to have your client available across all of your pages in your Svelte project, then the best place to put that would be in your Svelte layout component. So we're just going to bring in our client from Oracle, add our GraphQL URL to it, and then that'll be available to the rest of the project here. So with all of these examples, they're all just based off of the basic blog example. So just go off Git posts, display them to the user. So I really like using just like Routify to debug any output from a data request you're making. So in here, just getting the results from this query, putting them into the post query. You notice it's got a dollar sign there. Urkel uses swap stores, I think, to store that information. Okay, so that pre-JSON output, we get a spare output like this. So we have a couple of properties from Urkel. The most important one is fetching one. Yeah, the rest of the post data from the API endpoint here. So most of the examples are just going to be the index file, how that would look, and how that would look. So that's good. So over here, let's just make it a bit bigger. So we're just bringing in our operation store from Oracle here, and then we're passing our query off to it. And then we're using the Svelte expressions here just to work with the rest of that data and render that content out to the user there. So this is where that fetching property from Oracle comes in handy. You can just render out a loading spinner if you have any issues with that, or show an error. Otherwise, we're just going to render out the content here. Okay, so same thing with Houdini. Let's just take a look at Houdini. So Houdini is pretty neat with an NPX bootstrap, let's say. So you can do NPX Houdini generate, and it'll give you this environment file where you can put in your API endpoint. And this just gets put into the post method for this call here and returned as JSON. So this is going to be used pretty much the same as we did with the Urkel example. Just importing the environment here, set environment, and then using that at the layout level, so that's available to the rest of the project. So let's take a look at how that would look in an index file. Up the top here, we are getting a GraphQL query from Houdini. We're just requesting the title and the slug, and then we're just structuring that from the data posts, and then that's available to us so we can work with it with our Svelte expressions here. But, big but, what about linking credentials? So let's take a quick look at this. So this is that Houdini example I just walked through, running the dev here. So it generates all your queries for you at runtime. We can access them, just doing a quick hard refresh here, and then going off to the network panel, and we're looking for all the fetch calls. We're going to check out a post, and then we can go to the GraphQL endpoint here. If we check out the headers, we've got our bearer token, which is being exposed here, which isn't great. So if you take a look at the project here, with the environment setup file from Houdini here, I'm passing the secret token and using the import.meta.env from Vi here. Now I'm just setting up the authorization bearer token. And I'll just note just to say it demonstrates that secrets can't be used with Vi. So let's take a look at SvelteKit routes. So we've got file-based routing in SvelteKit. We have the index.svelte file we're looking at there, the layout file which contains our GraphQL client. We can also have our endpoint for our post here. We can also generate an endpoint pretty much the same way. So we've got our posts.index.json file here. The file notation index.json.js might look a bit funky. I've come accustomed to it now. I quite like working with it. But let's say we get an endpoint in SvelteKit. So that will be HTTP endpoint, get put, delete, etc. For this example, just adding in GraphQL client to the lib folder. And then just going to create a GraphQL client here with GraphQL request and passing our endpoint with our environment variable and also the secret token. And passing the header much like we did with our Urkel example. So let's take a look at that endpoint. So index.json is going to be where all the posts are for that endpoint. It's pretty small. So all we're worried about here is this get call. I can't really highlight it, but I'll try to go a bit wrong here. So we're defining our get HTTP call here. It's grayed out on the left. But what we're really worried about from here is getting the posts from the GraphQL client request here. And then in our index.svelte file, we can just call the endpoint directly with the fetch inside of the SvelteKit load function here. So the fetch is a SvelteKit wrapper for fetch function because this is before page mounts. And then we're just using that as we would, just returning the props to the page here. And then inside of our script tags, we're using more Svelte expressions to loop over the content to our posts here. Okay, so here it is with the GraphQL request example, spinning up the dev server here, hitting a hard refresh, force a habit, and I go over to the network tab, which isn't zoomed in, so apologies. It's clearing that tab there. And just go and make a request, and this will go off and get the slug.svelte endpoint here. And if you go over and check the headers, we're not exposing that bearer token. So that's good. We can also do the same for the pages endpoint here. And then we've actually got the endpoint for the post as well. So let's just take a quick look at how that was done in the code. So let's go to the roots folder. So we've got the secret token from our GraphQL client here. In our roots, we've got our posts, our software endpoint here, and we've also got all the posts as well, all via the post endpoint. Okay, so the bearer token, I didn't really, in the previous examples, there wasn't any need for a bearer token because we were just looking at stuff which was like publicly available. But if you were to do something like implementation in GraphQL, then you want that sort of thing extracted away. So you can do that in another endpoint. So there's a quick example of that. So it's going to define a mutation here. Going to bring out the variables from the request.body. I'm just going to pass those into the GraphQL client here, along with the variables. And then we should get our ID from the response from that mutation. So, closing comments. SvelteKit GraphQL, great client-side tools to use. Security credentials on the server. Don't feel bad about using server-side to secure your credentials. And that's it. So there's loads of information on the GossCMS blog from me. If you check out the GossCMS docs there. Also, more about me, you can follow me on Twitter or GitHub. Check out my site, there's loads of self-content on there, scottspence.com. If you want to have these slides, you can get them at SvelteKit in the content layer, app. And that's it. So, that's the end. We're going to flick back now to. Yay! Thank you! So, play from audio file.
Share.
Hi, I'm Dominikg, and this is part 2 of Sveltable vector graphics. Add HTML for the masses and componentless icons. In part 1, we saw how Add HTML can be used to optimize SVG icon components. And now I'm going to show you how to expand this concept with a Svelte preprocessor. A Svelte preprocessor can be used to change the markup of Svelte component files before they are compiled. And I have created Sweet.js Svelte preprocess SVG to process inline SVG before it reaches the compiler. After you have installed it, you simply add it to the list of preprocessors in your Svelte config. Make sure you add it at the end of the chain of markup preprocessors, especially after something like md-svex. Svelte preprocess SVG contains the same add HTML content transform we've seen before. It is enabled by default, but if you don't need it, you can disable it via its configuration. Another built-in transform is SVGO. You have to install SVGO as a dependency and then enable it via config. You can also pass custom SVGO options or add a custom SVGO config file and SVGO will load it for you. This helps you to cut down third-party inline SVG, and we'll see more about that later. But you can also add your own custom transforms. They only need a name and a function to manipulate the SVG. So you can add custom attributes, remove something, whatever you feel like. The sky is the limit here. Please share any useful transforms you can think of. If you don't want to process all inline SVG or want to process them differently, you can use filters for include and exclude, and also skip single transforms by file name, transform name, or SVG content. Now let's look at some results of running SVGO and add HTML over bundling all of Svelte feather icons. By default, it produces an output that's roughly 28 kilobyte gzip. With Svelte preprocess SVG, it shrinks down to less than 22 kilobytes gzip. That's more than 20% reduction. And even uncompressed, we're seeing 10% reduction. This is just some configuration you can add to your project if you are using a third-party icon library. You won't have to change any component code and you will get a smaller bundle output and more optimal Svelte SVG icon components. So give it a try. And now it's time for some real magic. We are going to make icon components disappear. To do that, we install Uno CSS, another great package by Anthony Fu. It uses the same Iconify library we've seen before with unplugin icons, and even the setup is almost the same, but it works very differently. Instead of importing virtual icons into your Svelte components, you import one virtual CSS file into your main JavaScript file, or your main layout file in a SvelteKit application. And in your templates, you simply use divs with classes to create your icon elements. In this case, logos Svelte icon is the same icon we've used before for unplugin icons, and you can style it however you like. And that's it. The Svelte icon is going to show up in your application. Uno CSS finds all the custom icon classes you use and generates CSS with data URL SVGs and also CSS masks so that you can still color them the way you like. The cool thing about that is that this code does not end up in your JavaScript bundle. Instead, it's going to end up in your styles. And that's a good thing. So with just 3 dev dependencies, less than 10 lines of Vite config, 1 virtual CSS module and 1 class per icon, we made all the icon components disappear. How cool is that? Wait, there's more. 1 extra dependency and a little bit of config. And you can also use Tailwind utilities. And a whole lot more too. But it's not production ready yet. So keep an eye out on Uno CSS and all the other cool things that are happening in this direction. It's going to be really, really great. So that's it for this talk. Thank you for listening. And thank you, Anthony and Joaquin, for building such awesome tools to help us all make better websites and apps. Follow the links on the right and see you soon.
Hi everyone, I'm Sid. I'm so happy to be here to speak about our journey to Svelte within our enterprise. I'm Sid. I have any Siddharth as my Twitter tag. I'm not so active, I just follow, and I'm a dark developer who just follows content and creating new ones. A little bit about my company. So I work for Schneider Electric. It's into energy and automation and digital solutions. We have been working quite a long time, and we are moving into the path of being a digital first company. It's a huge transformation for us. We have a lot of legacy systems in place, etc. We are spread around the world. So is our product that I'm going to talk about a little bit. And we are moving more and more into the sustainability space, and we work a lot with companies that have a huge passion for sustainability. Okay. I just want to talk a little bit about the product. So the product is called My Schneider, which is the logged-in experience for our customers, partners, distributors. We're live in about 140 plus countries, and we have 40,000 active users, and our potential customers are more than 500,000. A little bit about what we did. We structured our entire implementation entirely on Svelte. So we have the whole thing. So from Amplify, we used purely components, web components and Svelte components to bring this all together. And Routify is the backbone that supports us, along with Amplify to join all these dots together. We also are able to work in an extremely distributed fashion with different technologies, Angular, React, as long as they can output web components. We are able to achieve a lot of quick and easy integrations with several frameworks without any single page app frameworks and things like that, just by following these few integration guidelines. We insist on using web components for our distribution. Of course, there are a lot of arguments around performance of web components and the right way to use it, but we found it as a good common denominator to bring all people together from different frameworks. And thanks to Svelte, it's much easier to create web components with really little code. It makes it super easy to distribute this, not just in existing web apps, but also in apps with platforms like Salesforce, etc., which are super restrictive on what you can easily bring in. We use Routify. We were previously on Webpack, but we moved to Vite for about 6 months now. We're quite happy with it. We were on JavaScript. We still are for a big part, but we are moving progressively to TypeScript, and it still works. Amplify is our primary backend and also the hosting platform for us. Cool. So my goal is to tell you how we manage to convince our management and our architects and also partners and vendors in bringing Svelte onto the board. Some of the things that we learned along the way is the things that matter to us as developers on performance, the SSR, all those factors might not be the most important things when management is making decisions. The factors that would matter for them are how quickly you can onboard a team of vendors or partners or even your internal developers, and they won't really care about what goes beneath or behind the scenes. So we went with a path where we had a different technology that was supporting a design system, but I strongly recommend that if you want to have penetration for Svelte, design systems are a good way to start with, because they once it is there, they form the backbone of all the components that are going to be built, and it's much easier path to convince people to invest more and more on Svelte in using it and also building in them. Apps are much easier to target in an enterprise, primarily because you have the flexibility, you have less influence from the branding, and you don't have to really start worrying about SEO, SSR, and all those things quite early on. You can use the apps to then justify your marketing sites for stronger SEO, etc. But apps are much easier to start with within an enterprise, and it lets you experiment in isolation, which is definitely important. REPLs are extremely useful to communicate concepts, at least to get the word out and make business teams super comfortable with the word Svelte itself. I use it a lot to explain any concepts or explain even business concepts. I just open a REPL and I explain to them, think of it like in this box, etc. It's much easier, and they get more used to the name Svelte. So our app roughly looks like this. It's changed a lot over the time, but we are not known for our much fancier designs on this space because the audience we target are primarily expert users who knows our product quite well. And all the pieces that you see are coming in from either Svelte components, stencil components, or Angular web components all together on one single Svelte container. We use the word web components, or we use web components quite a bit to facilitate this. To have this as the least common denominator makes it much easier for us to embed this within our existing container and also other platforms like Salesforce and other services. We brought in all the component frameworks inside Svelte container. This is a huge win because although it's not the most efficient to load many runtimes of different frameworks, with a little bit of optimizations, we are able to just serve everything through CDNs. So if we decide to move certain component which is super heavy built on a different technology, we only have to deal with that specific component to integrate and not the entire application. We also reduce the dependency on NPM because although again it's not the most efficient, but using the CDNs to actually download the definition of web components quite easily made it super easy for us to decouple the specific component frameworks, because we can just say that all right, we'll publish your Angular components as web components into our CDN, and this will be okay, and we'll be able to retrieve it as long as we load the Angular runtime like Zone.js, etc. We've been going through this transformation for about 2 years now. We've learned a lot in slowly moving a lot of our existing apps into series of components plus APIs. We're still learning, but we're quite happy with what we've achieved so far. We have much more happier developers. There is less concepts that they need to really master, and as long as their HTML JavaScript concepts are good enough, and we don't enforce too heavy CSS changes thanks to our design system, it led to much cleaner code for us. It's not perfect, but it's much cleaner and easier to debug. Our onboarding has definitely simplified. We used to have a much longer onboarding. Now, at least from the code base standpoint, we could get people up and running in less than a day after knowing all the nuances of our project. Thanks for taking the time to watch my talk. Happy to chat about it on Twitter or Discord, anywhere else. Thank you. Have a good day. Hi everyone, I'm Sid.
Really good.
Yeah, sorry for all the technical issues because we had to anyway, shift to different laptops and all that, and they had to fix the sound system here as well. But anyway, Anthony's here. He's just joined us. So
Literally just walked in.
yeah, he just walked in. So thanks for joining us. Even despite the technical issues that we've had
Thanks so much.
this evening. Anthony,
Thank
anything
you.
you want to say?
It's been brief.
And Pete, Penguin, we forgot to say something about the COC.
Well,
That's all right.
This campsite now.
You want to announce it?
This time. We now have a start COC. We haven't got a link though. I haven't got a link.
It's not like the that ready, so
You can review it.
it's public though.
I feel like I'm bending down to talk to somebody here.
I
There's
know,
a camera's there.
Yeah. Anyway, we had to obviously
So
improvise.
there's a COC on the Svelte GitHub repo. It's still a PR, I think. It is merged on its name. It was a PR this morning. I think I saw it get merged. You can view it and feedback, obviously.
Appreciated. And welcome. Very welcome.
Okay, thanks everyone. So we're going to sign off now, and hope to see you at another mini summit. And thanks, Kevin. Kevin's
Merry Christmas, everyone.
in the background.
Merry Christmas.
Yep.
Thank
Enjoy
you, Kevin.
Christmas.
Thank you, Karen.
It's ending.